Hello and welcome back to the Blade of Akaya channel. You are watching Shenzhen I, and in the last episode we had some quite complex problems to solve with the logic, and in the end a mass of labels helped me to to produce the board that I wanted to do, where I only used one single MC6000. Anyway, it's time to move on to the next design. I think we've got an email to look at first. So this is from Tilly. Hey y'all, yeah. Sometimes it's tough to represent how a word really sounds in text, huh? Take, for a totally random example, Shenzhen. How would you say it? What's the ZH doing in there? Can you just ignore that H? Spoiler warning, you can't. ZH is its own sound in Chinese. We don't have time to go into all the fun foibles of pinyin, the official romanization system for Mandarin Chinese, so let me just give you a little shortcut. Say Shenzhen, which is what I've been doing, people, because I know that ZH is a zh. You know, like you're talking to your best friend Jen. And, well, when you're probably closer, then you're probably closer than you were before. How's that for confidence? I'll do one more. The Chinese yuan is the currency here. The word is one syllable. I hear people go yuan or yuan, and well, that's kind of painful. I'm not sure how to fix this quickly. How about trying to say yuan really fast? You're still making two sounds instead of one, but maybe it's closer, maybe. By the way, we use yuan as a currency, the Y as a currency symbol, which you might have associated with Japanese yen. The Japanese yen, I've just read that twice because I said JPY is Japanese yen. Associated with JPY, the Japanese yen, and it's also CNY, Chinese yuan. Look, don't you dare give me side eye if you come from a place that uses the dollar sign, because do you mean Hong Kong dollars, Australian dollars, Canadian dollars? Yeah, at least we can probably agree that dollar signs, yuan signs, means hella cash. Hella. Really? Anyway, now you're wandering around Shenzhen buying things in Chinese yuan like the super pro that you are. Pronunciation can be tough, but it's worth putting in the effort, ain't it, y'all? I tell you what, I find her emails really difficult to read compared to everyone else's. I guess it's the constructs that throw me in there, but anyway. Yeah, so it's Shenzhen, and it's yuan, said very abruptly, I guess. Yeah, I thought it should have been Hong Kong dollars, but apparently in this game it's using the Chinese yuan. Yuan Nimbri, or whatever it's called. Anyway, we're going to look at this design here. Infrared sensor, important. So Lily Wu is saying, I am in the process of setting up closer tie-ups with total global firms. Total global? I cannot read today. With top global firms, and am working to secure higher profile work for our company. The first result of these efforts is a contract to create an infrared sensor. This allows us to participate in the booming market for passive monitoring stations to detect illegal activities, illegal carbon emissions, illegal growing operations, illegal immigration. If it's against the law and it generates heat, we'll detect it. Lily woo. Okay, let's have a look at this design. And I've started naming the designs. I've gone. Oh yeah, there it is. Passive infrared sensor. So I am going to name this PIR, passive infrared sensor -D1 design 1. Okay. If I make a subsequent design, it gets to D2. And that's the naming convention I've used back on some of the other designs. I haven't renamed them all yet, but I'll get there. Right. There's new players on the board. Okay. RTC is a simple input connected to a DT2415 real-time clock module, which is one of those. No, hang on a minute. That's the clock module must be in there somewhere then. A sensor is a simple input connected to the infrared sensor. Okay, alarm is a simple output connected to a silent alarm. Over here. You can't actually, I've noticed that for some reason Fraps isn't picking up the mouse cursor. So unfortunately you can't see where I'm pointing, which is kind of annoying. So I'm going to have to best describe that the sensor pin is over on the left hand side and the alarm pin is on the right hand side. The alarm should be turned on whenever the sensor reads at or above 20 between the specified on and off times. Okay, so off. Okay, looking at this one here, the off time is 20 and the on time is 93. Okay, the on and off times are set by the operator using switches that can be read as X-bus inputs and use numerical values compatible with the DT2415. Okay, this is, I think, starting to get quite complex now. Okay, so the RTC has this going on, so I guess 95 to 0. It doesn't quite get to 100. The sensor is an input that we don't have any control over and does this. Right, so okay, I'm not sure how we use some of this stuff. I'm going to try an MC400 to start. So we're going to need a signal in there. No, MC4000, sorry, isn't going to work because I have more than 2 inputs. So that's going to go in there. And then I think if we have is one an input, one an output? I don't know. I don't know. This is confusing. Right, let's put oh, no, too many. Let's put that there. Let's put I don't know if this is going to work. Let's put that there, and I'm assuming that I can put pin type mismatch. Excellent. Okay, so that. Are you joking me? I've got to have. Aha. Can I do it that way? What's that for? No. There. Can I do it that way? I don't know. I literally have no idea what I'm doing with this set of kit at the moment. I should I should refer to the documentation, but literally I'm going to try and wing it for now. So I want to. I'm hoping. See, I don't know about this. I mean, this diagram on the RTC unit is suggesting that the RTC output is coming out of that bottom pin, in which case I need a pin. So I'm not sure if I'm going to get anything on X0. So just for fun, what I'm going to do is move X0 to AC sleep 1, and I just want to monitor the input part not sleeping blocked on read. Right. I don't think that's going to work then. Right, let me just throw one of these in, chuck that there, and then chuck that there, and then I'm going to need to pass through move P0 to X1 sleep 1. Let's try that. Yeah, okay. Yeah, we have something now. Wait a minute. Right. I need to use these to block this signal, really. So what I'm going to do is I'm going to move this out for a minute. I think actually I don't know that I need that MC6000 there. So let's just do that. Let's delete that for now. That's got to go there, right? Then, I shouldn't have deleted that other one. Right. Anyway, let's just do that. Okay. Let's delete that. Get rid of that. Get rid of that. Then, so the RTC is going to go to pin. So I'm going to put that there. That. Then I've got to put that. Do that. Then oh, hang on a minute. I've got two. Oh. Yeah, no, okay, alright, I can't have... If I've got to move this over, then I might as well do it like this. Okay, do that. Then I can have X2 go to there, and then like that. Maybe I can have this waiting on X0, and then if that is greater than 20, let me think about this. Okay, I think what all I need to do is perhaps just say check if P0 because you know, over time at some point this should get hit, so test if P0 is equal to X0. If so, move. Actually, I don't know what's less power consumptive. Move 1 to dat, or just AC. And then otherwise test equal P0 to X1, and then I think we have to jump here, so jump to end, which I'll set up later. Otherwise test equal P0 X1. If it is, then move 0 to ACK, jump, end, and then if I do end, test equal just thinking. Yeah, test. No, I just move ACK to X2, right? Because all I need is a 0 or a 1. I don't need full power for it. And then I can wait on this, and then I can say if P0 is greater than 19 and test equal X0 1, move 100 to P0. If I say no, then jump to end, then test equal, yeah, move that, otherwise move 0 to P0. No, it's not P0, it's P1. P1, and then end. End will do nothing in this. End will just sleep 1, I guess. And then here we need to sleep 1, I think. I don't know. I don't know if that's right, but you know, come on, let's try it. And we're blocked. Part not sleeping. Which part? Which part isn't sleeping? Yeah, we can test that. We can test that. Move ACK to X2, which we've done. Then that's greater than, if that's greater than 19, which it is not, jump to end, then sleep. And that's where it falls over. Okay, in looking at the documentation, there is a limitation in using the X-bus pins, in that if I'm sending data down an X-bus pin, I have to read it the other end to unblock the thing that's doing the writing. So unfortunately, in this logic that I've set up down here, I'm not going to do anything until pin 0 goes high, or higher than 19. Now the problem with that is that I never read from X0, which therefore means I'm not receiving the output given to X2 on this device. So what I'm going to do is basically fudge it by moving, right, that's going to change to ACK, and then I'm going to remove a line from here, and then I'm going to move X0 to ACK. Now hopefully that will unblock. Actually I can get rid of that as well, because I thought I needed some kind of feedback loop when I don't, which means I can now get rid of that and all of this, and then get rid of that line as well, and then let's put another gap in there just to tidy up our instructions. Right. let's just see if that is right now. Okay, we've received the signal. We're testing. We're going to jump to the end and sleep. But now we're blocked again. I guess I could just end no op. And then wait for a signal again. Hang on a minute, I'm never sleeping. Okay, right. Sleep. Sleeping. Okay, let's try and simulate this now. In fact, I'll just do it to here. At the bottom, you can see we're getting into the start of where we're supposed to actually be doing stuff now. So, we jump to the end, we move the ACK to x2, which is 1. We're sleeping. We're now moving x0 to the ACK, which is now 1. Yep, that's fine. And then we're going to see if P0 is greater than 19, which it is. We're going to see if ACK is 1, which it is. I'm going to move 100 to pin 1. Yeah, that works. That works. That works. It's still working. It's still working. Right. Here is where I don't know if it's going to work, because it says the off time is 20 when in fact the off time should be 2. So let's see. Okay, test equal P0 equals x1. I don't think that worked. No, see, that's not worked. Well, that's blooming marvellous, isn't it? So even, right, no matter what, at this point, we need to move 0 to P1. So whenever P1, so whenever P0 is less than 20, we need to be sending 0 to P1. Whatever else happens. And now that works. Now we've got a different curve. Yeah, that works. Now it doesn't. Why didn't that work? Right. Okay. Because... Right. Because it is actually supposed to be 20, and all of this stuff I've done here is wrong. Okay. So I don't need that. That's x0, right? Step, jump to end, move. No. Wait a minute. What have I done here? What, move ACK to x2. 0 to ACK. And this should have a move 1 to ACK. Right? Okay. So I basically removed too much logic there, I think. Yeah. Okay. Okay. Advance, advance, advance. Yeah, that's dropping now. So let's get rid of the breakpoints there. Simulate. It's working! It's working! Right. I'm gonna reset because I need to remove all of this crap. Because we don't need that. Let's remove that. Because it's using power that we don't need to use. Right. I don't think there's anything I can do there. There's nothing I can do to make this that I can think of right now. There's nothing I can do to make this more power efficient. So each run, each run is running 544 power usage. Okay, well, I'm in there with the bulk of everyone else. Yeah, okay. I guess, you know, there must be some kind of improvement on this one, but I'm not going to dwell on this one too much. What I'm intending to do is, for the most part, go back over some of these and just see if I can be more efficient with them. But yeah, I'll do that another time. Maybe I'll do another video on it later on. Anyway, let's return to mail. What have we got here? Just letting you know that your design for the infrared sensor component was well received by our partners and is set to be integrated into a number of products currently under development by various defense and security firms. Obviously, our performance here opens the door to more jobs of this nature, so thank you for contributing to Longteng's future. So Carl's saying, hang on, we're becoming a defense supplier? Have you got a problem with that as well, pal? This guy's a bit of a moaner. Right, working remotely. Note that I will be working remotely today and maybe tomorrow, just in case you are looking for me in the office. And Joe saying, that's weird, I thought you got back from your trip yesterday. Haha. And then Lily Wu saying, I did, I've been stuck in a traffic jam on the way back from the airport since then. And then Carl says, you've been in the same traffic jam for over 24 hours. Lily Wu saying, when a city grows as fast as Shenzhen has, it's natural to expect there might be some strain. I'm fine, I have food and water in here. Wow. And Ji Zhang says, maybe next time a virtual meeting is better. So the traffic's so bad. There's another storyline, right? We're going to have to do something with traffic signals, surely. Improve traffic flow. I don't know. We'll see. Right. Prototyping new ideas. Carl Teskey. Sometimes a decent product idea falls out when you're faffing about with chips and code and the like. So I've set up an empty prototype board for us to experiment on. On you go then. Chips. And then Ji Zhang saying, we can test with some different parts too, such as custom LCD panels. I will add other new parts as we receive them. Kolteski says, custom LCDs, are you serious? That's brilliant. We could make retro style handheld games. Let's all take turns designing one. Carl, come see me. If you have finished all your other assignments, I have more work for you. Who's this Carl fellow you mentioned? Nobody we know. Design and create an electronic game. Click and hold this button to indicate you have completed the objective. Prototyping area. New design. Game. D1. Let's go with that. And then open design. This is just so we can muck about. Holy cow, there's all sorts of stuff in here that I'll have to get used to. Okay, I've decided that today I can't finish this. It's a lot more complicated than I first thought it would be, but at the end of the day, this is just a prototyping bit. It's not actually part of the main progression through the game. So I'm going to come back to this when I've had a chance to kind of work on this a bit more offline. You'll have to ignore all this gubbins down here. That was just so I could actually kick off a simulation. But yeah, I'm getting into quite a lot of complexity around figuring out the position of stuff. So there's some real funky stuff you have to do around understanding whether I'm here or here or here or here, and what I'm going to actually do in the event that I am in those locations. So like I said, I'm going to leave this one for now and crack on with the next part of the story, and we'll hold off on clicking that because we haven't finished anything. So virtual reality buzzer. Create a working design for this product to view. Oh yeah, no, they say that on every one. Okay, so David P. Solomon. Hi all. Apologies for the personal side here, but I've met this wonderful girl named Zhao Mei, and well, to make a long story short, she's set to move in with me next month. There's just one small issue, and it's something I thought maybe we could create a product to help with. See, when I'm doing my VR sessions, it's easy for someone to sneak up on me because I can't see or hear them. Awkward to say the least. This inspired me to think up a product, a simple vibrating buzzer that attaches to a VR headset so it can be felt during the most intense sequences. Connecting that to a radio controller, I could place the button outside of my study and Zhao Mei could buzz me when she needs me, with no chance of being caught by surprise. What do you think? I'm sure plenty of other VR enthusiasts might find themselves in a similar predicament, and this is a solution inexpensive enough to be an impulse buy. So Joe says, congrats David. And G says, note about the radio chip you will be using. Normally, reading X bus causes the microcontroller to block until data becomes available. However, this radio has a non-blocking X bus buffer. The non-blocking buffer will immediately return a value of -999 when no data is currently available. Should make it easier. G. Okay. Let's get in there. So let's rename this. So this is VRB D1. Virtual Reality Buzzer Design 1. Okay, so there's the radio. Right, straight off we can see there's an RX and a TX. Now RX is receive, TX is transmit. We're only going to be interested in transmit in this scenario, because we won't need to send anything back to the buzzer. So it says down here, radio RX is a non-blocking X-bus input connected to a radio receiver. Buzzer is a simple output connected to an electromechanical buzzer. When a data packet is received over the radio, read it and execute the corresponding command in the following table. Okay. So 0, power off, 1, power on. Sounds simple enough. Right, so it's going to send -999 the whole time. So what I'm going to do is test equal x0 neg -999, jump end, I think if we make end sleep 1, I'm not sure how that's going to pan out at the moment. Yep. Otherwise test equal x0 to one, and then we're going to say move 100 to P1, otherwise move 0 to P1. How's that going to work? Let's have a look. Oh, okay. One. Oh, it wants... Oh, damn it. It wants a pulse. So if I do this now, part not sleeping, blocked on read. Okay, it can't have a sleep. So end will be a nope. No op. Part not sleeping, blocked on read. What's he talking about? I guess you have to have an SLX in there. Let's try that. Yeah, okay. So something's going wrong. So that's minus 999, which we were expecting, and then now what's it doing? Wasn't it doing anything? Oh, for goodness sake. Receive? Oh, okay. Alright, that's me being a dullard. Okay. This is the radio receiver for the radio that picks up the radio transmission from something else. So sorry, I was being a bit silly there. So, right, okay. Part not sleeping. Well, it said not to sleep. Okay. It's not doing anything. Right. Bang, 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 bang. Bang. Okay, and this should be false. This should be true. Why isn't that? Ah, right. Okay, what's going on is that the value is being consumed really quickly. So, what I need to do is store. So we need to go move x0 to ACK and then test ACK instead. Right, let's try that. Right, okay, we're going high when we need to. We're just not going low. Right, I think I can, but I think I need the bigger block. So I'm gonna cut all of that, get rid of that, put this in place. So like so. Right, so that just slots in, and then what I need to do is move that into DAT, not ACK. I need to test DAT. Right, and now I don't see how I can do this with one board now. It's not working. I have to use two boards now. Ah, I've got it. Right, so when I move 0 to dat, I need to move also 0 to ac. Job done. Finally did it. Okay. Yeah, it looks a bit overpowerful. And wow, I really am doing the lowest of the low, so I'm going to have to come back to that one at some point. Anyway, let's return to email. Wonderful, this is exactly as I had imagined it. Okay, right. Anyway, I'm going to call this episode here. For me, it's been rather lengthy. I'm going to have to chop loads out because of that prototyping shenanigans in the middle of it all. I hope you enjoyed it. If you did, don't forget to hit like, share and subscribe, and I shall see you all in the next episode of Shenzhen I. Thanks for watching, and bye bye for now. Human hack. What? What the hell? What the hell? O2 supply activated. Angular acceleration